Oh, third time. Welcome back. We're going to have some fun in this session. We're going to talk about the way we as humans can interact with machines, and we're going to show you a series of different examples. We're also going to see at the end of this session who the explorers are with these new technologies. We're going to see two projects, for instance, that artists have made with the Oculus Rift. So interesting stuff. First of all, though, we're going to have a talk that shows how perhaps there is an underlying concept, how there could be an integrated way to develop further and fluent machine interactions. We're delighted to have Thomas Bendig here. He's the CEO of the Fraunhofer ICT Institute. Now, Fraunhofer is really big. There's 19 institutes and there's over 5,000 experts, usually PhD people and beyond, working on the most advanced technical matters. A lot of things are coming out of Fraunhofer. For instance, the MP3 standard underlying all the music distribution that was made possible on the internet came from the Fraunhofer Institute. They think about this in a very methodological way, and we're really interested to hear from Thomas Bendig on intuitive natural machine interfaces. Thomas Bendig.
Well, thank you for this nice introduction. Wow, I'm really impressed of this great conference center, and even by the number of people that are here at the Next 14, despite there are a lot of other very interesting events during the Web Week here in Berlin. I want to talk about next generation user interfaces, because we need new user interfaces, because we constantly add new functions to our mobile devices and to our software and to our other systems. Let me give you an example. 3 years ago, the smallest or the biggest smartphone on the market had the size of this. Today, this is one of the smallest smartphones on the market. But we see a lot of devices that are increasing in the size, and we see smartphones in the size of this. And there you see the problem. We try to shrink the size of all devices, but because we constantly add new functions to these devices, we see increasing screen sizes. But bigger screens, in most cases, lead only to bigger buttons or more buttons on the screen. What we really need is simplicity and intuitive user experience. Because people like simplicity. And we should keep in mind that most people like simplicity because they don't want to learn how to use a mobile device or a mobile application. And in a lot of situations, people need simplicity because they have to focus all of their mental and cognitive power to the current situation and not on thinking about how to use a mobile device or a mobile application. Think about a situation on a train station where you have exactly 2 minutes to figure out where the train leaves, from which platform. There you want to fight with a mobile device with a small display. You just have to ensure that you will catch your train, and you have to do it within only a few minutes. And these are these situations where you need a simple device, a simple user interface. But what is simplicity? If you think about it, you will recognize that you will get different answers depending on your point of view. The most efficient way of interaction is the human communication, at least for a human being. Because if I'm telling you, wave your hand, then you know exactly that I'm talking to you, because I use a lot of parallel information channels. I used speech, I used gestures, I used my gaze, and from the intonation, he didn't know that I mean it seriously, and I'm not kidding. But what's so easy and intuitive for us is a very complex problem for a computer or a mobile device. Until a few years ago, it seemed to be impossible to develop a computer that is able to understand people. But today's devices are becoming more and more powerful. And in the past, the CPU power and the processing power have been the limiting factors for new services and new applications. But with these new devices that are connected to the cloud, we have nearly unlimited computing power. So today, not the CPU is the limiting factor for new applications and new services, but it is the user interface. So even we have very powerful devices in our pockets that are connected to the internet and to clouds, still the user interface is lagging behind. And there are two main reasons. One reason is the way software is developed. In most cases, the developer starts implementing the core functions of the software and then wraps some kind of user interface around it. And this is very bad, because when somebody tells you the user interface is important, then he's lying, because the user interface is everything for the user. For the user interface is the application, is the device. So when you start to develop a software or a device, you should start the development process with the user interface, and you should develop the user interface together with the user, with the customer. And the other reason why the user interfaces are still lagging behind is that these traditional interfaces are simple multimodal user interfaces. A long time ago, we had only a keyboard to give input to the computer. And then we developed additional input devices like the mouse, the joystick, a pen, a touch screen, and so on. But all these devices optimized a specific task. And all these devices are very uncomfortable for a lot of other tasks. So all these devices are used separately. And with these multimodal user interfaces, we gave the user the chance to choose which interface is used best for a specific task. But the problem is that the user had to choose, and the user had to switch between these devices, and there was no seamless interaction. So there are a few ways to improve these user experience and bring it to a new kind of user experience. Of course, you should start the development of all devices and applications with the user in mind, and not with the functions in mind or the devices in mind. Then you should remember that in the real world, there are no controllers integrated in our hands. So usually people want to control the world without anything that is fixed in their hands. In our real world, we have controllers like a light switch or a doorknob that we could grab with our plain hands. And that we should keep in mind when we develop new applications. We've seen a lot of new technologies like gesture recognition, speech recognition, face recognition, gesture tracking, and gaze tracking. But all of these technologies are used very isolated for a single task. And this is the reason why even these great new developments didn't lead to a very improved new user experience. But the chance for a new user experience is if you combine all these types of input to one user interface, and you use all these different information channels at the same time, and the user could use all these channels at the same time and could act with these interfaces like he would act in the real world. And so we would see a shift from a multimodal user interface to an omnimodal user interface. For instance, if you imagine you're dictating a text in front of your computer and the phone rings. With an omnimodal user interface, the user turns his head and is talking to the telephone, and the speech recognition recognizes that the user doesn't look to his computer and stops speech recognition and text dictating. And when the phone call is ended and the user looks back to his computer and continues to dictate the text, then the system knows, okay, now he's looking in front to the screen, and the user could continue speech recognition without any interruption, any additional command, or any additional interaction. And even in virtual environments and augmented environments, it would be a great enhancement if the user could activate virtual objects with a combination of gaze, gestures, and speech, because this is a very challenging problem in all these virtual environments and these augmented reality environments. The user has the chance to use all these natural interactions at the same time as he would do in the real world. And two other things could help to improve the user experience a lot. The first one is to reduce the overall user interface through context sensitivity. If the system knows what happens around the user and what's the current situation of the user and what's the current goal of the user, you could dramatically reduce the user interface and shouldn't bother the user with actions that don't make any sense in the current situation. For instance, when we can detect from the gyroscope in a smartphone what the user is currently doing. We see if the user is driving with a car, if he's walking, or if he's driving with a bicycle. And if we know this, we could adapt the user interface to the current situation. And if you know more about the current situation of the user, then you could adapt the user interface much better to the current situation. So if the smartphone or smart device that you carry with you knows more about you and your current situation, then it could help you much more better, and it could show you only functions that are suitable in the current situation. And in the current smartphones, we see a lot of sensors that could help the device to think about the current situation and what could be your current goal, and then it could offer you only a few options of support to reach this current goal. And another way of improvement in the user interface is to make these devices smarter. Today, we control every device with specific commands, with device-specific commands, and interact with each device separately. With things we've seen yesterday here, with this, if this, then that, we can make a lot of things automatic. So there we have a smart assistant in the middle. This could be the gateway of a smart home that controls a lot of things for us, depending on rules that we gave him before. And even this reduces the user interface, because a lot of actions doesn't have to be controlled by the user, but happened in an automatic way. And maybe in the future, these devices will interact with each other and the actions that the user has to trigger will reduce to a very few. And of course, with these devices, we do a lot of configuration, installation, adaptation tasks before these devices work as we wish it would work. And there is also a big potential for improvement if these devices would learn for themselves to install, to adapt to our life and to our usual tasks, then it would help a lot and we could reduce the user interface more. And one other thing would be the result of this if we could use a lot of natural interaction with these devices, like gesture recognition, like speech recognition, gaze tracking. Then we don't want to talk to devices with menus on the screen. So I think in the future we will see much more faces on these screens. I think Siri was just a starting point where you could start to interact with your device by speech, but maybe in the future we will see digital assistants with faces on these devices where we could interact nearly like with a real human. Thank you.
Thank you. Stay here for a minute. Thank you for providing a framework that we could use when we think of, all these different devices and how we interact with them. At the time, long time ago already, the Fraunhofer could develop the MP3 standard because it was a non-profit institute and it could give it away to the world and everybody could take it. Are you also trying to develop a sort of a framework or a standard for this kind of interaction? Is there a software platform or a framework that would make sure this can happen? Because you need a lot of players to take it.
Yes, we're working on such frameworks, and there are two directions of development, because if the system knows so much about me, about my life and about my situation, then there are two directions where it could go. The one direction is that you use the computing power of the cloud, because it's much more powerful than the simple computing power of one small device. And the other way is that to try the same without sending too much information to the internet, but keeping it closed on my personal digital assistant, because it's my privacy.
This also becomes against a privacy decision. So where do you think it will go? Will both platforms or both directions be explored?
I think we will see both, because the cloud version will be much more powerful at the beginning, and but a lot of people will then think about their data and where it is stored. So I think we will see a trend in the other direction when the cloud solution
and the platforms that you try to, or that you are developing at Fraunhofer, are they cloud-based or are they trying to keep the data closer to the user?
We do both.
Okay.
Because we don't know which user decides for which solution.
You are working on this now. When are these platforms coming out and how? I mean, how do you introduce such a big framework to an enormous market?
I think you will first see smaller versions of these frameworks, because if you're too generic, you fight a lot of additional problems. So you have to reduce the function set. And I think in the next or over next generation of mobile devices, you will see such platforms.
And you will work closely with the mobile operators to
Yes, we're working with these
yeah.
companies. Because Fraunhofer doesn't bring products to the market, you won't see a Fraunhofer phone, but you will have Fraunhofer technology in a lot of devices, even that you already own.
It's in all your hardware anyway. Thank you very much.
Thank you.